Hi and welcome to our edition of Mind Map. Mind Map here is referring to the Mind Map for Maintaining Database Security Part 1. So we'll quickly be zooming into the threats. Okay, what are the threats that will try to jeopardize the databases? So the threats can either come from a few sources. One would be insider, outsider, and then also it will explain the effects of the losing of data. So what is an insider? An insider can be an employee, a student, or contractor that is granted a higher level of trust than other outsiders. The vulnerability of this is that the accessibility of the information, which is offered tight performance, meaning information is open to unauthorized access, change, or disclosure of information, and is susceptible to interference or disruption of system services. Ways to mitigate the insider threat. Although it's important to extend a certain level of trust, there should be some controls in place to prevent an employee from taking advantage of a situation for their own personal gain. So for example, you provide network file shares so that the employees don't have more than what they can have, legacy permissions, data portability, and logging and monitoring so that every time you try to make an access, they try to access, you make changes, they log it, and they monitor it for you. The next threat will be the outsider threat. Well, outsider threat can be things like organized crime, espionage, activists, like anonymous, and anyone who attacks the system from outside the company. So for the attacks of outsiders, they have two different types of attacks. One would be the active, one would be the passive. The active one generates packets or participates in the network, while passive is mostly eavesdropping the network or tracking the users. More of like what would you do with personal data and such. To mitigate this, we have to follow the procedure of CIA, and what we know as we learned from back then, CIA stands for confidentiality, integrity, and availability. So for confidentiality, you need to start with the database server. It needs to be secure in order for enforcement of confidentiality. And also I have to authenticate users so that only authorized personnel are given permission to see the data. As for integrity, the data store must be accurate and has not been altered by unauthorized personnel, meaning that when you alter something, it must be accurate. You cannot be like deviating away from others. And availability, which is backup, and when you need the data, it must be available when needed. Alright, next up we'll be talking about the fundamental components of SQL Server 2005. The first one will be principles, second one would be securables, and the third would be permissions. Now what are principles? Principles are groups that request access to SQL Server objects. They are categorized into two groups, the indivisible and the collection. Now what are these? Indivisible. The indivisible is an entity that exists separate from other entities. So your examples will be like the Windows login and the SQL Server login. Whereas for collection, it is a group of entities collected, existing existing as one, even though they are comprised of separate entities. And what are they? There are things like the Windows group and the SQL Server rules. Now principles can be defined at three levels. The first level will be the Windows, which applies to the local administrator, the domain user accounts, and the groups, local and domain groups. It can also be defined under the database, which involves the user, the rules, the application rules, and the SQL server login, and the server rule. Now we go to securables. Securables are objects and resources to which SQL Server 2005 controls the access to. And so there are three types of securables. They are defined at three scopes, which is the server, the database, and the schema. At server level, there are three scopes to be defined. There are further three scopes to be defined, which is either the servers, the logins, and the databases. And for databases, it has I think about 5 different scopes, which is covering the users, the roles, the application roles, and the symmetric and symmetric keys, and the catalog. Whereas for the schema itself, it controls access to the tables, the views, the function, procedures, synonyms, and the aggregates. Now we go to permissions. Permissions are the type or level of access granted. And so there are two types of permissions. One is either object and one is statement. The object, it controls how users work with data. Let's say you have control alter, you impersonate, you create, you select, you insert. Those are examples of object permissions. As for statement permissions, it applies to statement used to create or alter the server database, and the statement permissions to the database administration. So examples would be like create database and create table.
In this section, we will be discussing about securing the server scope. Securing the server scope is important to ensure only authorized users can access SQL Server. There are two main authentication modes. First is the Windows Authentication Mode. In Windows Authentication, access is granted by a login mapped to a Windows account or group the user belongs to. The advantage is that one can enforce password policies such as maximum password age, minimum password length, and can also enforce password history. The disadvantage is that anyone running on Mac OS, Linux, or any other OS cannot connect to the database. The other authentication mode is SQL Server Authentication or Mixed Mode. In SQL Server Authentication, the user logs into the network and opens a non-trusted connection to SQL with the user and password. It is not trusted as SQL doesn't trust the OS to verify password, so don't be confused on this part. Then, if the SQL server matches the user password entered and the entry in the sys.sys logins table, access is granted. So that concludes the part on securing server scope. Thank you. In this section, we are going to discuss the concepts of contained and non-contained databases. In a non-contained database, important information such as login accounts is not stored on the database itself, but rather the server instance it is in. Thus, in an event of database migration or restoration, those important information has to be identified and moved together to the new instance. This process can be extremely time-consuming and difficult for database administrators. So in MS SQL 2012, contained databases were introduced. Such databases are isolated from other databases and the instance of SQL Server is hosted on. Usually, it's a common practice to allow some features beyond the database boundary to be enabled, and hence giving rise to a partially contained database. The partially contained database has several advantages. Firstly, it allows for movement of database from an instance of SQL Server to another without having to copy logins from source instance to target instance. Thus, it allows for more efficient migration compared to previous version of MS SQL. For example, login information can be stored in the database itself, thus eliminating the need for manually identifying the login information and moving it to the new instance. Second advantage is the always-on availability groups. In the case of a failover, which is switching to a standby copy of a database, contained users will be able to connect to backup database without creating new logins for the instance that is hosting the backup database. And the third advantage is that it contains settings and metadata required to define the database, and there's no dependencies on SQL Server instance. Hence, as settings are managed on the database level, The database owner or administrator has more administrative control over the database without the need for sysadmin permissions. So that concludes the part on contained and non-contained databases.